Hello everyone, my name is Jonathan Nicholas from Information Technology. Today we are going to dive deep into the most critical component of any computing system. We often call it the brain of the computer, but technically it is known as the Central Processing Unit or the CPU. Whether you are using a smartphone, a laptop, or a massive supercomputer, the processor is the component responsible for interpreting and executing almost every command you give. When you look at a processor visually, it looks like a small, flat square of silicon. But if we cold shrink or fill down and go inside, you will see a microscopic CD with billions of tiny switches called transistors are turning on and off at light speed. In this video, we are not just going to talk about what it is. We are going to break down its structure, meaning what is inside it, and its function, meaning how it actually works to run your programs. By the end of this expansion, you will understand actually what happens inside the chip. Before we get technical, I want to give you an analogy to help your visual the process works. Imagine a professional kitchen. In this kitchen, the hard drive or storage is the pantry. It's where all the ingredients or data are stored for a long time. The RAM or memory is the kitchen countertop. Is where you put the interface you are about to use right now. So, who is the processor? The processor is the head chief, head chef. The chef does not hold the food forever. His job is to take ingredients from the counter, chop them, cook them, and plate them. In computing terms, the processor fetches data from memory, processes it, and sends it out. The relationship is simple. The set is CPU work very fast. If the countertop is RAM, is too fast, small, too easy. Is too small or lazy. The shape slow down. If the battery is storage is too far away, the shape is weak. But the shape himself, he is the one doing the actual execution. Now let's open up the shape. Is bright and see the storage. Processor is just one solid block. Inside, it is divided into three main units that work together. These are the control unit, the ALU, and the register. And number one, the control unit. First, let's talk about the control unit or the CPU. If the processor is the chef, the control unit is the chef brain or focus. It directs the flow of data. The control unit doesn't actually do the math. Instead, it tells every other part of the computer what you do. It reads the instruction from your software and decodes them. It says, okay, Mali, send this data here. Or Elu, please calculate this number. It is the manager of the entry operation. And number 2, the arithmetic logic unit. Second, we have the ALU, standing for arithmetic logic unit. This is the method of the processor. This is where the actual work happens. The ALU performs 2 types of operation. 1. Arithmetic. This is basic math like addition, subtraction, multiplication, and division. And 2. Logic. This involves comparison is greater than this value true or false. Every video game play every calculation in Excel eventually boils down to this simple math and logic question answered by the ALU. Number 3. Register. The third structural component is the register. Going back to our kitchen analogy, the RAM is the countertop, but the register are the chef hands. Registers are tiny, extremely fast storage location inside the CPU itself. The processor cannot process data directly from the RAM. It is too slow. It must first grab the data and hold it in a register. There are special types of register, such as number 1, the program counter or PC, which keeps track of which step in the recipe to the next. And number 2, the interaction register (IR), which holds the code component being executed. And last, the accumulator, which holds the intermediate result of a calculator. So, to summarize the structure, the control unit derives the ALU calculator, and the register holds the intermediate data. Know that we know the parts. How do they move? How does the processor function? The processor operates in a continuous loop called a machine cycle of the fans called execute cycle. The cycles perform billions of times per second. Let's start one single cycle. Step 1, fetch. First fetch. The control unit requests instruction from the RAM. It is like the chef looking at the recipe book to see what to do next. The instruction travels from the RAM through by system bus and lands uh, in the processor interaction register. And step 2, decode. Second is decode. Computer only understand binary 0 and 1s. The interaction might look like 10110001. The control unit reads the code and translates it into a signal. It figures out this code means add the number 5 to the number 3. Step 3, third execution. Now the control unit comments the ALU. It sends number 5 and 3 to the ALU. The ALU performs the addition or produces the result. It is the moment the processing happens. Finally, there is often a fourth step, store. The result, the number 8, is read back into a register or sent back to the RAM memory so it can be displayed on your screen or used later. And immediately after that, the cycle repeats fetch, decode, execute, fetch, decode, execute over and over again. Before we finish, you might wonder if our processor is weak by our side faster than other. This brings use of clock speed and cost. Clock speed, measure the gigahertz, is basically how fast the fans decode, execute, cycle speed. A 3 gigahertz processor can perform 3 billion cycles per second. And what about cost? Remember our chef analogy, 8-core processor. I like having 8 chefs in the same kitchen. They can all fetch, decode, and execute different interactions at the same time. It is why modern computers can run a game, a browser, and spotty all at once without freezing. So, to wrap up our session today, the processor is a complex system concept of the ALU format, the control unit for management and register for speed. It functions by directly regulating and fetch, decode, execute, cycle to turn your code into reality. Understanding the structure gives you a better application of the technology we use every day. Thank you for listening. I hope this explanation helped you understand the fascinating world of computer architecture. See you in the next video.